Here from Beet 1/1. Okay, so from my part, I would like to present about abstract. Okay, a direct radio frequency sampling receiver front end concept was experimentally tested, assessed, and compared to a traditional heterodyte receiver front end that requires signal down conversion before sampling. The goal of the study was to demonstrate that employment direct RF frequency does not have a negative impact on a signal power and phase. The sampling rates utilized in this investigation are very much low.
Assalamualaikum, my name is Fatihah binti Muhammad Nudin. Today I want to talk about introduction of this project. So first, what is radio frequency? Radio frequency is the rate of oscillation of an alternating electric current or voltage or a magnetic, electric or electromagnetic field or a mechanical system that is within the specified frequency range. Then the frequency is made into a radio wave, which is energy from an oscillating current that can radiate a conductor into space. To determine different upper and lower bounds for the frequency range is from different sources. Then the application of radio frequencies is electromagnetic fields, radio wave, microwave and wireless signals are used in various electronic equipment. It is also applied in broadcasting, satellite communication, heating industry, and so on. Then it is used in radio receiver to provide selectivity while allowing only the appropriate frequency band to enter the end of the set. It can ensure that the undamaged signal is not transmitted in the transmitter. It is also used to avoid mixing the products that are needed after going to the next stage.
Lower than the carrier frequency while more than twice as larger as a signal bandwidth. A bandpass filter is placed in front of the analog to analog digital converter to prevent the sensitivity loss caused by analyzing out of a band noise and interfering signals ADC. An RF energy harvesting system primary goal is to convert incoming ambient RF energy is usable DC electricity. The result shows that the direct RF sampling achieves performance comparable to heterodyte receiver mixing.
Basic type of radio frequency contain 4 types of filters. These filters work different in reject or accept the signal. It is possible to receive and reject unwanted signals by using the right type of radio frequency filter. The 4 basic radio frequency filters are low pass, high pass, band pass, and band stop. Each filter have their own application.
Assalamualaikum warahmatullahi wabarakatuh. My name is Anabila binti Muhammad Rozi and I will present for the low pass filter. Low pass filter is a filter which will pass only low frequency signal and attenuate or top high frequency signal. For this filter, inductor prevent high frequency signal from passing and allow low frequency signal to pass. Next is passive filter. These filters are known as passive filters since they are made of passive simply connecting resistor and capacitor in series with the capacitor. If we keep the RC low pass filter. Next is active filter. The filter is named as an active filter because they are constructed using active component or component that add energy. In filter, the most commonly used active component are operational amplifier, or we call it as OM. First order active low pass filter is basically a filter that is composed of only one reactive component capacitor accompanied with an active component OM. This is example circle and the graph for the first order. For the second order active low pass, it can be created from the first order low pass active by adding additional RC method. The stop band of the second order, it will be twice from the first order, which is 40 dB per decade. If you look at the second graph, the graph is more stable range rather than the first order. This is because the graph is twice, which is 40 decade, and the slope of the graph is more sharp than the first order. The term of cutoff transfer to point in the frequency response of a system where the energy going into the system start to weaken rather than pass through. Passband is the band of frequency before the cutoff. So from zero and before the cutoff is the passband, and stopband is the band frequency after it. So the frequency and after it is the stopband.
For my part, I will explain about high-pass filter. So, what is high-pass filter? It is a filter that passes higher frequencies while blocking lower frequencies. High-pass filter also have first, second, third order, and other. The most important parameters for radio frequency are cut-off frequency, bandwidth, attenuation, insertion loss, and power. Then, I will explain about how it's working. High-pass filter built around a cut-off frequency, which is the frequency below which attenuation is high and above which loss is very low. And high-pass filter allows signal above the cut-off frequency to pass easily, while dampening signals below the cut-off frequency. The sharper the cut-off frequency transition, the higher the order of the high-pass filter. So this is the circuit, which is passive high-pass filter circuit. The circuit contains input voltage across the capacitor and resistor in series and have output voltage at the end of the circuit. The capacitor in the circuit configuration has a very high reactance at low frequency. It behaves like an open circuit and blocks all input signals at Vin until the cutoff frequency point is reached. Then, above this cutoff frequency, the capacitor reactance has sufficiently decreased to behave more like a short circuit, enabling the entire input signal to pass directly to the output, as shown below in the response curve of the filter. Then, this is the active high-pass filter. This circuit is using an operational amplifier in the circuit, one capacitor and two resistors with the input voltage and with output voltage. As implied by its name, a first-order single-pole active high-pass filter attenuates low frequency while passing high-frequency signals. It merely consists of a passive filter portion followed by an operational amplifier that does not invert. So this is the frequency response of high-pass filter. At low frequencies, the signal is attenuated or damped, with the output increasing at 20 dB over decade or 6 dB over octave until the frequency reaches the cutoff point where R equal to Xc. It has a response curve that extends from infinity to the cutoff frequency, with the output voltage amplitude being 1 over 2 equals to 70.7% of the input signal value, or negative 3 dB or 20 log V out over V in. At frequency, the phase angle of the output signal leads that of the input signal.
Hi, my name is Priya Darshini Ramaningam from Beet 1/1. Today I'm going to present about bandpass passive filter. A passive bandpass filter is classed as a second order type filter because it has two reactive components within its design. The capacitor. It is made up from two single RC filter circuits that are each first order filter themselves. The passive bandpass filter can be used to isolate or filter out certain frequencies that lie within a particular band or range of frequency. The cutoff frequency or FC point in a simple RC passive filter can be accurately controlled using just a single resistor in series with a non-polarized capacitor, and depending upon which way around they are connected. So this is the simulation circuit for passive bandpass filter, which is we are using inductor, capacitor, resistance, and this is the output. So next is about active filter. Active bandpass filter attenuate frequency below and above a range of frequency. Any signal with the frequency within the bandpass range passes easily through the filter. Any frequency outside of the bandpass is attenuated or reduced. There are two basic types of active bandpass filter. First is switch capacitor and continuous. Switch capacitor active bandpass filter are clock device. The input signal is sampled at I rate and processed discretely instead of on a continuous time basis. Continuous active bandpass filter have a continuous time operation. So next is about cutoff frequency. The bandpass filter is a combination of two filters, therefore it has two cutoff frequency. One cutoff frequency is derived from the high pass filter and it is denoted as FCI. The filter allows the signal which has the frequency more than FCI. So this is the pictures of the cutoff frequency. So next is about the bandwidth of bandpass filter. The bandwidth of a bandpass filter is defined as the range of frequency of the filter's pass band, or the frequency from the low cutoff to the high cutoff frequency.
Assalamualaikum and salam sejahtera. My name is Nur Izzati binti Anwar Muzaffar. My matching number is P0821105556. Now I will explain about the band stop filter. The band stop filter is formed by the combination of RC low pass filter with a RC high pass filter. Band stop filter block or reject frequencies that lie between its two cut-off frequency points, such as frequency low and frequency high, but pass all those frequencies at the side of this range. Okay, the band stop can be divided by two types, which is passive types and active types. The band stop filter is another type of frequency selective circuit that function in exactly the opposite way to the band pass filter. If the stop band is very narrow and highly attenuated over a few hertz, then the band stop filter is more commonly referred to as a notch filter. Notch filters are designed to provide high attenuation at and near a single frequency with a little or no attenuation at all frequencies. Notch filter use a twin parallel resistance capacitance, or we can call as the RC, network to obtain a deep notch. The band stop filter have many uses in electronics and communication circuits. Okay, they can be used to remove a band of unwanted frequencies from a system, allowing other frequencies to pass with minimum loss. As I said before, the band stop filter have a two-type filter, which is a passive filter and active filter. Okay, passive filter have a three passive component, such as a resistor, capacitor, and inductor. Are connect in series. Okay, the input voltage is applied across the resistor, and the output voltage is obtained across the inductor and the capacitor. Okay, then for the active filter, notch filter is called twin T-notch filter or parallel T configuration. The resistor and the capacitor in the upper T section form the low pass circuit. Okay, then the lower T section form the high pass filter circuit with a resistor and capacitor. Okay, this is the example circuit of the band stop filter. Firstly is a passive types without op-amp, and secondly is the active types which has op-amp. Okay, now I will explain about the formula for the band stop filter. Okay, the formula for the high frequency, low frequency, and bandwidth same as the band pass filter. So now I just want to show the formula for the notch frequency and the quality vector for Q. Okay, firstly, notch frequency equal to 1 over 4 multiply pi n RC. Okay, secondly is the quality vector for Q. Q equal to notch frequency divided by bandwidth.
Application of RF filter. RF filter is widely used globally to make our life easier. Electronic user filter in a variety of applications, and radio frequency is one of the principal applications. They are utilized radio receiver to keep the activity and to allow proper band frequency to access the latter part of the set. Filters are applied in multi-way signal transmission by sending a designated frequency over a chosen path while utilizing various bandpass, high-pass, low-pass filter combination. For low-pass filter, it can be found in audio amplifier, equalizer, and speaker, and they are utilized for things like anti-aliasing, speech transduction, and speech processing. Any high-pass filter also can be used in image processing. It is for sharpening the depth of image, and for bandpass used in wireless communication medium, the transmitter and receiver circuit. In transmitter section, this filter will Only request signal and reduce the interfering of signal with other session. In receiver session, you will have from advantage signal penetration into the channel.
Hi sir, I'm Priyanka Sukalingam here. So I would like to present about the discussion. In this project, we need to design a circuit for a low pass passive filter, active filter, which is first order and second order active low pass filter by using multisim. Besides that, we have assumed that the frequency from 20 Hz to 10 kilohertz and observe the output of voltage, whereas we need to calculate the output of voltage in dB as well. After that, the cutoff frequency and bandwidth need to observe by observing the graph as a result. Moreover, the same step has been repeated for the passive band pass filter, but the frequency that we key in form of 200 Hz to 15 kilohertz.
Lastly, the conclusion is the installation of the live filter in the circuits helps to improve the quality of the RF signal which is transmitted and received in the communication system. Okay, this is because in a receiver, they filter all incoming RF frequency to avoid interference. Meanwhile, in a transmitter, they filter much of the transmit generate harmonics, wideband noise, and out-of-band conversion